Hello, my name is Astakhova. I am studying for a bachelor degree at Department of Media System and Technology at Kharkiv National University of Radio Electronics. Today, the topic of my research is development of a custom-designed lamp using FDM 3D printing technology. Today, several 3D printing technologies are available. Each possesses unique characteristics and fields of application. Among the most popular are SLA, SLS, and FDM. I choose FDM especially due to its cost-effectiveness and ease of use. Fuse depositing modeling operates by extruding melted thermoplastic filament layer by layer to build up a three-dimensional object. Everything begins with the idea, what exactly you want to create. In my case, it's a lamp with custom design. The first step involves preparing an image. It could be anything, even a photo, but I especially prefer an illustration. So I will demonstrate how to prepare one for 3D printing. To achieve the highest possible quality, it's important to use vector illustration. I have already created one in Adobe Illustrator and divide it into multiple layers: background, text, and decorative elements. Each layer is saved as a separate SVG file and the entire illustration is additionally exported as a regular JPEG file. Next, we need to transfer our illustration into a 3D model. For this task, I'm using ThinkingCAD software, which is user-friendly, free, and doesn't require a powerful computer. But while ThinkingCAD has a limited functionality compared to more advanced software, it's ideal for our specific needs. Of course, for more complex and detailed projects, Fusion 360 would certainly be preferable. So, in ThinkingCAD, I create a new project and importing each SVG element. The image aligns perfectly after importing. Then I set the background thickness to 1 mm to allow sufficient line transmission. I elevate all the other elements to the background height and set their thickness to 0.5 mm. Finally, I export the completed model in OBJ format. For the base of the lamp, I also have my own life hack. Let's open MakerBoard, navigate to the Maker Lab section and select Make My Lithopen. Originally, this server was developed to generate lamps specially from the photographs, but I have ought to use an illustration instead and manually adjusted it for improving quality in the final product. After creating a new project, we are offered several options. I select multicolor printing with a LED strip and upload our JPEG illustration. I make the dimensions a bit bigger, then download the completed project choosing settings compatible with my printer model and nozzle size. At this stage, I will physically prepare the printer before continuing with model preparation. First, it's necessary to decide on the filament type to use. Generally, there are many different types of plastic filaments available. PLA or PLA Plus is the most affordable, easiest and safest plastic for printing, but less durable and not resistant to high temperature or water, offering only moderate strength. PETG is stronger and water resistant but require more carefully handling during printing. ABS is very strong but toxic, make it unsuitable for printing in space without proper ventilation. They are the main filament type, but of course many others exist, such as soft rubber-like, ultralight, or dedicated support filament. For this lamp, standard PLA is perfect. I use PLA filament from Yasan and Bamboo Lab. They offer an optimal balance between price and quality. Next, I determine specific color: black for the base of lamp, white for the background, blue and purple for the illustration itself. Since the illustration is multicolored, I use the automatic material system for my Bamboo Lab X1C printer, loading any additional required colors into it. Then I choose the plate. Several different plates are available for various tasks, but my primary criterion is a smooth finish without texture. The Bamboo Lab Cool Plate Super Track is ideal for this purpose. I remove the default plate that's currently installed, take the cool plate, clean it with alcohol, and carefully place it back on the printer. I continue preparing the model in a slicer, a specialized software that converts three-dimensional digital objects such as STL or OBJ files into a set of two-dimensional layers, generate G-code. This code contains instructions that control the movement of the printer head, speed, temperature, lighting, and other parameters critical for printing. While a lot of slicers exist, I use Bumblelab slicer since my printer is a Bumblelab model. First, I open the lamp-based file in the slicer and import the illustration model as well. Next, I proceed directly to configuring the printing settings. Initially, I select my printer Bumblelab X1C with a 0.4 mm nozzle. Then, I select the plate that I will be using and update the model's color according to my previously chosen filaments. Additionally, I always increase the nozzle temperature for the first layer, ensuring a more stable and high-quality foundation. After setting these parameters, I click Slice and review the results. I activate the travel view, which visualizes the path the print head will take during printing. Here, it's apparent that the path is overloaded, which could result in unpleasant strain and require additional post-process. To optimize the print head movement, I enable the optional Avoid Crossing Walls, setting it to 300. I also activate ironing, ensuring the top layers become exceptionally smooth. All other settings remain at their default values. Now the model is ready for printing. I will start with the lamp base. Now while it's printing, I have time to buy a LED strip. Of course, I could order the specialized branded LED strip from the official Bumblelab website, but it's quite expensive and requires waiting for delivery. In reality, its specifications are no different from the LED strip available at IKEA. So that's where I go to pick one up. I'm choosing the simplest and most affordable option, but of course IKEA also offered multicolor LED strip that can be controlled via smartphone. By this time the lamp base has finished printing and ready to be removed. Carefully I take out the plate and gently bend it to deattach the printed part. If necessary, I can assist this process using a specialized blade. Afterward, I reinstall the plate onto the printer and begin printing the illustration. Approximately 5 hours later, once the illustration is completed, I repeat the same steps to carefully deattach it from the plate. At this stage, post-process would typically begin. Usually I use a small gas torch along with sandpaper with different grit levels to refine the printed surface. However, the print turned out so perfectly smooth this time that additional post-processing is unnecessary. So I immediately proceed with assembling the lamp, attaching the LED strip to the base and carefully fitting the printed illustration into the designated grooves. The lamp is now fully assembled and ready to use. This project clearly demonstrates the potential of FDM technology for producing functional and aesthetically pleasing interior items. Such an approach significantly boosts individual creativity in lamp design, make it practically relevant for designers and small-scale manufacturers who seek cost-effective solutions in custom interior decoration. Thank you for your attention, and bye!